Okay, 9.1, exploring rational functions using transformations, part 2, writing equations. The vertical asymptote writing equation. So a couple key facts here. The vertical asymptote provides the h parameter, okay, and then the horizontal asymptote provides the k parameter. To algebraically determine the a parameter, substitute a known value from the graph into the equation and solve for a. So this is similar to a lot of the other like log functions, exponential functions, quadratic, radical functions. Similar process on how to write an equation. So example 1, to determine the equation in the form y equals a divided by x minus h plus k for the given graph. So right away I can see that I have a vertical asymptote at x equals -2, and then I have a horizontal asymptote at y equals -4. Okay, therefore, my h value is -2, and my k value is -4. And then I'm going to, right here, conveniently, I'm going to use point -1, -1. And that's my x and y values. And let's see where we go. So y equals a over x minus h plus k. Let's fill in x equals -1. Oops, I have -1, -1. That's x, y. Okay, let's fill everything in. So y is -1. A I'm solving for. X is -1 minus h, which is -2. And then plus k is plus -4. Okay, -1 equals a divided by -1 minus -2 is -1 plus 2, that's 1, and then that's -4, so that's -1 equals a minus 4, and 3 equals a. And so when I come back to my equation, y equals a over x minus h plus k, I have y equals, my a value is 3, over x minus h, which is -2, plus k, which is -4. Let's clean it up. Y equals 3 over x plus 2 minus 4. There's my equation. Okay, example 2. Determine an equation of a rational function that has an asymptote at x equals 4 and y equals -5. Is there only one possible function that meets these criteria? Let's see. So x equals 4, that means h equals 4. Y equals -5, that means k equals -5. So let's take our general form, y equals a over x minus h plus k, and let's plug stuff in. So y equals a over x minus 4, and then plus k is -5. All right, and then we just need a possible equation. Determine an equation. I don't have a point, but let's make a plausible equation. I'm going to say let a equals 1. Therefore, I have y equals 1 over x minus 4 minus 5. So this is a possible equation. Is that it? A can be any real number except a does not equal 0. And you can write an infinite number of equations with these two asymptotes and any a value not equals 0. Also, don't forget about Joe rational squared. I can also do this, folks. Graph it and see what you find out, but this also produces asymptotes at x equals 4 and y equals -5. And it's a Joe rational squared, but it still works. So give it a graph and find out. Okay, next one, folks. Example 3. Consider the function g of x equals 6 divided by 15 minus 3x minus 8. Rewrite the equation in the form y equals a over x minus h plus k, and describe the transformations of g of x from the graph of f of x equals 1 over x. So This one we need to rewrite it in terms of our general form. So if I have y equals a over x minus h plus k, let's make g of x look like that form. So 6 over 15 minus 3x minus 8. Okay, so the a value looks good, but I need to do something with the denominator. The k value looks good, so I'm going to do this. Let's factor. First, let's reorder it, not changing the value, just reordering it, and then let's factor that denominator and see where that gets us. 6 over, I'm factoring out a negative 3, and that's x minus 5 minus 8. And so let's take a look at all of our transformations. What's going on here? And the h value. Now that b value, what I can do here, folks, I know we didn't write it in terms of that, but we can do it like this. A over b times x minus h. And this makes sense from what we know on transformation. So that b value will go right here. Okay, so let's write out all of our a, b, h, and k values. So a equals 6, and that's a vertical stretch about the x-axis by a factor of 6. Likewise, b value, negative 3. That is a horizontal stretch about, this time, the y-axis by a factor of, so this one, just be careful, that's 1 over absolute value b, so it's 1 over 3. So that's your factor. Also, since b is less than 0, that is a reflection in the y-axis. And then h equals 5. That is a horizontal translation, 5 units to the right. And then k value of 8, that is a vertical translation, 8 units, that's positive, so 8 units up. Oops, oh man, my bad. K value, sorry about that, folks. K value is negative 8. Sorry about that, so it's negative 8 because it's plus k. So my mistake there, let me fix that. So that should be 8 units down. Okay, on to example 4. For each function, algebraically determine the equation in the form y equals a over x minus h plus k. Verify your answer with technology. So we're going to do it using 2 methods. First, let's take a look at this. We want to put this into a form where we have one rational expression, then we have a number. How do we get from an entire rational expression to a split? That's the problem. So if I look at this, here's the problem I have. If I do this, I'm going to split up negative 5x over x plus 2 minus 1 over x plus 2. Well, I still have variables in the denominator. I need to split it. This needs to be a k value. This needs to be the rational function. How do I do that? So how I do that is with a little clever manipulation of the numerator. So if I think about this negative 5 and this 2, negative 5 times 2 equals negative 10. So why do I do that? So let's take a look. if I do y equals negative 5x, let's go minus 10 and plus 10. So that is just 0 effectively, and doesn't change the expression, the value of the expression or the equation. Minus 1 divided by x plus 2. Where does that get us? Let's rearrange. At y equals negative 5x minus 10 plus 9 divided by x plus 2. And then now if I split it, watch what happens when I split it up, is negative 5x minus 10 divided by x plus 2, and then plus 9 over x plus 2. And let's factor the numerator, negative 5, that's x plus 2, divided by x plus 2, plus 9 over x plus 2. Well, look what happens. X plus 2 divided by x plus 2 is 1. So all the way up here, folks, I have y equals, that's negative 5 plus 9 over x plus 2. And let me just spin it around. Y equals 9 over x plus 2 minus 5. And I am in the form y equals a over x minus h plus k. Okay, let's try method 2. That's using synthetic division. Oh, you got to remember from the polynomials unit. So this is using synthetic division. Okay, so reminder here, y equals negative 5x minus 1. Let's label the pieces parts here so remember what we're dealing with. This is your dividend, and this is your divisor. So when we set up our synthetic division, that's negative 2. I put my negative 5 here, and I put my negative 1 here. And let's go. So that's bring the negative 5 down. Negative 2 times negative 5 is positive 10. Negative 1 plus 10 is 9. This is your remainder. And then this is your, remember the result of division is your quotient. So what do I do with this? Let's write this one out. Remember, p of x divided by x minus a equals q of x plus r over x minus a. So that's negative 5x minus 1 over x plus 2 equals, what's the quotient? That's negative 5 plus what's the remainder divided by x minus a. So that's remainder is 9. And then the x minus a value is x plus 2. X minus negative 2 or x plus 2. So the finished product here is 9 over x plus 2 minus 5. And you'll see that it's exactly the same as there. So two different ways to do this. Okay, folks, letter B. We're going to do two methods. So y equals 2x plus 1 divided by x minus 4. So the first method is the factor method. I'm going to go 2 times negative 4. That's negative 8. Why do I do that? Because I need to set up my numerator so it will factor out with the denominator so I can get that k term. So that's 2x, and I take negative 8, and I add back 8. So I'm not changing the value of the equation, plus 1 divided by x minus 4. Now we split it up. Plus that 8 plus 1 is 9, so that's 9 over x minus 4. And then I factor the first term, so 2 times x minus 4. Perfect, look at that. 9 over x minus 4. Y equals, so x minus 4 divided by x minus 4 is 1. That's 2 plus 9 over x minus 4. And let me just spin it around, write it in the form. And I have y equals 9 over x minus 4 plus 2. Let's use synthetic division on the other side. Okay, so when I set this up, I'm going 4. The divisor is 4. And then I have 2 and 1 in the dividend. And then I bring down the 2. 4 times 2 is 8. 1 plus 8 is 9. So this is my quotient. this is my remainder, my r value. So recall p of x over x minus a, so the polynomial divided by the divisor equals the quotient plus the remainder divided by the divisor again. So this is our equation from synthetic division. And so I have 2x plus 1 divided by x minus 4. That was what we originally started with. The quotient is 2. The quotient is 2 plus the remainder is 9 divided by the divisor is x minus 4. And so if I spin that around, that's 9 over x minus 4 plus 2. And that is the same that we have from the start. One more, folks. Y equals 2 minus 6x over x minus 5. Let us rearrange that, method 1. Let us rearrange that as y equals negative 6x plus 2 divided by x minus 5. Okay, what do I need to do? I'm going to go negative 6 times negative 5, and that is positive 30. So I use that 30, negative 6x plus 30, and I subtract out 30, so I'm not changing the value, divided by x minus 5. And let's evaluate. I have y equals negative 6x plus 30 divided by x minus 5 minus 28 divided by x minus 5. And so that's y equals negative 6 times x minus 5 divided by x minus 5. There's my two matching binomials, minus 28 over x minus 5. And let's finish this. X minus 5 divided by x minus 5 is 1, and that's y equals negative 6 minus 28 divided by x minus 5. And let's spin it around and write it in order. So that's negative 28 divided by x minus 5 minus 6. So there's method 1. Let's do method 2, folks. So I'm going to set up 5 as my dividend. Sorry, 5 is my divisor. Okay, and then my dividend is negative 6 and 2. And so bring down the negative 6. 5 times negative 6 is negative 30. 2 plus negative 30 is negative 28. And so there's my quotient, and there's my remainder. Okay, so polynomial divided by my divisor equals, that should be an a, equals the quotient plus the remainder divided by also my divisor, x minus a. So my polynomial I started with is 2x plus 1 divided by x minus 4. Quotient is negative 6 plus the remainder is negative 28 divided by my divisor is x minus 5. And let's clean that up, folks. That is negative 28 divided by x minus 5 minus 6. And is that the same as before? Yes. So there's two different ways to rewrite this in the form. Remember, the whole goal is we're trying to rewrite it in the form y equals a divided by x minus h plus k. Howdy, folks. Application time. So I have this situation with books. Marlise is producing a tourism booklet for the town of Atlin, BC, and its surrounding area. She is comparing the cost of printing from two different companies. The first company charges $50 for a setup fee. Think of that as your flat fee just for starting. And then $2.50 per booklet produced. There's a second company she's considering. The second charges $80 for setup and $2.10 per booklet. State the average cost per booklet for each company as a function of the number of booklets printed. So, company number 1, linear equation, right? So when I set this up, I'll say y1 because you'll graph this in your graphing calculator. Y1 equals $2.50 per booklet, so X is booklet. number of booklets plus a $50 setup fee. So I'll just say X for each. X is number of booklets okay, where n is an element of natural numbers. And then here y1 is total cost, company number 1, company 2. That's y2 equals, let's see, $2.10 per booklet, so 2.1 times x, which is the number of booklets produced, plus an $80 setup fee. So y2 equals total cost for company number 2. Average cost per booklet, so average cost per booklet. Well, that is just total cost divided by number of booklets. Okay, so which in this case would be for company number 1, that is y1 average equals 2.5 x plus 50 divided by x, that's the number of booklets. And then number 2, let me do number 2 in blue, is y2 average equals 2.1x plus 80 divided by x, the number of booklets. So when I graph this on my graphing calculator, it looks something like this. So here's, here is the first function. And then here's the second function. y2, and then here's y1. Okay, and then let's answer some questions about this. Also, here, key point here, the intersection point. This is at 75 and 19/6, which is x comma y. All right, let's answer some questions here. Explain how the characteristics of the graph are related to the situation. So 1, only showing quadrant 1, y. Let's think about this logically. Quadrant 1. Let's think about this logically. Why? Domain is n is an element of all natural numbers because books are represented as natural numbers, such as represented as 1, 2, 3, ... all natural numbers. Okay, cannot have decimal or fraction values of booklets. They have to be whole booklets. Because of this, therefore, all the costs are positive, which further confirms that we're only showing the graph in quadrant 1. So this is in quadrant 1. Number 2, what other characteristics? Vertical asymptote at x equals 0. So x equals 0. Okay, average y. So let's write it out. Average cost per booklet increases as number of booklets decreases. Well, this should sound familiar. So average cost per booklet increases as number of booklets decrease. So as I go this way, number of booklets decreases, the average cost increases. And that makes sense, right? Because of that flat fee that you start with, these two flat fees. Okay, and what I just described, right? Number of booklets decreases, average cost increases. That is your end behavior as x approaches 0. You can think of it that way, end behavior. All right, next one. How about our horizontal asymptote? So describing end behavior, horizontal asymptote, where is that located? At y equals 0. So back to the graph. Y equals 0. Average cost per booklet decreases as number of books increases. Okay, and that is also describing end behavior in the other direction. So as number of books increases, average cost decreases. Kind of makes sense where the more you order, the less it costs per unit, so per book. That should make sense. It's kind of like bulk purchasing, right? You go to Costco and buy lots and lots of toilet paper or ketchup or, I don't know, celery. You're going to pay less per unit the more you buy. So that kind of makes sense. Last one. Let's talk about the intersection. Intersection at 75, 19/6. What does that tell you? You print 75 booklets. Okay. The average cost, because it's an intersection point, think systems of equations, average cost is the same for both companies. Okay, last part. Give Marlies advice about how she should choose a printing company. So how would I do this? Let's consider intersection point at 75, 19/6. Or let's put it in dollar terms. Still 75 booklets, comma, $3.17. 19/6 as a decimal, $3.17 per booklet. So given this information, what decisions can Marlies make? So case 1, if Marlies wants less than, that breaking point is 75 booklets, which company should she choose? If Marlies wants less than 75 booklets, then this way. So what company is cheaper if I do less than 75 booklets? Well, company 1 is, right? The red line. If Marlies wants, so let me highlight that just to show. So in green, I will highlight it, the cheaper parts. So less than $75, I want to choose company 1. So less than 75. If Marlies wants less than 75 booklets, then choose cheaper option with company 1. If Marlies wants more than 75 booklets. Then which company should Marlies choose? Then choose cheaper option with company. And let's take a look. So in green highlighter again. So at the breaking point, right? What's the cheaper option? Well, it is the blue line this time, right? So the cost is cheaper. So greater than 75 booklets produced, you want company 2. Choose company number 2. That's it.